Good evening, everyone. Hello. Okay, it's 7, so let's start siguro at 7:01. Hello? Hello? All right, so okay, let's start. Share ko lang yung screen ko. Okay, so ang uh, webinar natin, topic natin for tonight would be IP addressing and subnetting. So I'll just give an introduction siguro about sa mga i-discuss natin and some expectations. So this is probably one of the most challenging topics, I guess, for most people getting into network engineering. Just because of yung part na merong math, okay? So I understand maraming hindi masyadong mahilig sa math. But yun nga, what most people don't know is that yung understanding IP addressing, subnetting, and yung fundamentals ng binary counting sets you up for yung subsequent topics from yung basics hanggang sa intermediate all the way papunta dun sa mga advanced topics. So this is a very important topic. Hindi natin siya pwede skip. Otherwise, you'll have a hard time understanding everything else. Okay? So if you have a pen and paper, labas yun na. So you just be ready for some computations. Okay? So yun. Okay, all right, so let's start. Okay, so we'll start with the parang short review lang. Yung about sa IP addresses, we kind of touched on this already nung sa network layer deep dive webinar natin. So as we've seen so far, ang IP addresses are used for logical addressing, di ba? So kung natatandaan nyo, we assign yung IP addresses to computers and also sa routers. Okay? So in the case of computers, meron siyang network interface. Yun, ina-assignan yun ng logical address, which is an IP address. And the same thing with routers, meron din naman siyang interfaces. In fact, multiple interfaces, right? So ina-assignan din lahat yun ng IP address. Okay, so I'm depicting yung difference here ng logical address at nung physical address, which is yung MAC address or hardware address. All right. Then another thing that we've discussed is yung yung paggamit ng IP addresses in terms of yung communication between hosts, right? Computers. And actually any kind of device that runs IP. So yun yung bottom line. So IP addresses are used in IP headers dun sa sa destination and source address para yung mga computers they will be able to find each other, right? And we know nang tumutulong doon is yung routers to be able to identify yung kumbaga location ng isang host sa isang network based dun sa destination IP address. Alright, so let's dive right into yung anatomy ng IPv4 address. So, ano nga ba yung itsura ng IPv4 address? Okay? So, I'd like to I'd like to point out dito na we'll be talking about IPv4. Okay? So, we've introduced yung IPv4 versus IPv6 the last time yung sa network layer, right? So, lahat ng itatakal natin for today is puro IPv4 lang. Okay? So, yung, kumbaga, what we've been using for ever since nung nag-start yung internet. Okay? So, yun. So, based on what we have here, an IPv4 address is, composed of 32 bits. Okay? So, 32 bits siya. So, either a 1 or 0. So, 1 bit is either a 1 or a 0. Okay? So, remember that. Ang 1 is naka-on and then yung 0 is naka-off. Okay? So, 32 na ganon. And as we can see here, we have either, kumbaga parang equivalent niya, nung 32 bits na to, it's broken down into 4 octets. Alright? So, ang isang octet is equal to 8 bits. So, kaya nga siya octet, di ba? Parang 8 ang kumbaga pinaka-root word niya, right? So, 8 bits is equal to 1 octet. So, being 32 bits, it's 4 octets siya. And also, on the other hand, we can say na since ang 8 bits is also 1 byte, pwede rin natin siyang sabihin na it's made up of 4 bytes. Okay? Yun. So, let's go into yung binary math na tinatawag, right? So, pagdating kasi sa binary, okay? So, as we've said, it's made up of ones or zeros, right? So, kaya nga siya binary because there's only 2 possible values. Okay? So, yun, the 2 possible values lang. And then, as we can see here, right? So, yung different positions na to, yung ones and zeros na yan, they are, there's a certain meaning applied to them. Okay? So, if you notice from left to right, okay, yung pag-count niya is exponential. Okay? So, let's start from from right to left pala, from my perspective. Hold on, let me just enable yung aking pointer. Yan. So, nakikita yung pointer ko. Yan. Let me make sure na viewable pa rin. Okay. Yun. So, from here sa rightmost part, right? Mag-umpisa tayo sa 1, right? And then 2, 4, diba? Pa-counting towards the left. 8, 16, 32, 64, 1 to 8. So, padoble siya ng padoble, right? Every step towards the left. Okay? So, ganun yung pag-count dito. Okay? And what I want to point out here is yung anything that is turned on. So, in this case is ito, yung pang 7 from the right and yung pang 8 from the right. Okay? So, ibig sabihin ito yung dalawang pinaka-leftmost bits are turned on. Whatever their value is, 128 in this case, tsaka 64, yun yung i-add natin. Okay? So, yun yung magiging value nitong octet na to. Okay? Or itong byte na to. So, 8 yan. 1, 2, 3, 4, 5, 6, 7, 8, right? And ang value ng lahat ng to is yung value ng lahat ng naka-turn on na bits. Okay? So, in this case, 128 plus 64. Okay? So, if you add that, ang kalalabasan nito is 192. Okay? 128 plus 64. Yun yung value niya. Excuse. Okay, so let's move on dun sa octet structure. Okay, so each octet structure. Okay, so medyo may overview na tayo from the last slide, but just to reiterate, di ba? So lahat ng bits na naka-on, so if naka-1 ka, ibig sabihin yung kasama ka sa pag-add. Okay, so in this case, ang example natin dito is lahat naka-on. So, lahat is turned into 1. So, 255 lahat yun. Pag in-add mo lahat ng 128 plus 64 plus 32, 16, 18, 4, 2, 1. Okay? So, 255 lahat yan. And obviously, kung lahat naman 0 is 0. Right? So, yun lang. So, meaning, ang kalalabasan nito, okay? Ang pinaka-kalalabasan nito is there will be 0 to 255 and in total 256 total possible values. Okay? So 0 to 255 yung pwede maging value niya. That means 256 total possible values. And ang equivalent din nito, if we try to double check this, would be 2 raised to 8. Okay? 2 to the power of 8, right? Equals 256. So, yan yung kumbaga typical na pagbibilang natin in terms of yung binary. And if syempre if i-expand natin dito, yan 2 times 2 times 2, yan. Makikita nyo naman, di ba? So ang total niyan is 256. Okay? So yun. Alright, so let's have some binary counting examples, okay? So if you have yung pen and paper nyo, or maybe tawag dito, if you want to use a calculator, it's alright then, di ba? I'll give you a chance here to sort of do a short exercise. So there are 4 examples here. Siguro I'll give it 2 minutes. Okay? 2 minutes para mag-compute. Okay? So go through it, itong 4 na example na to, and we'll just start now. Okay, so we just went past yung 1 minute mark. So 1 minute to go. Alright, so that's about it for our 2 minute exercise. Okay? So I hope na kuha nyo siya. Okay? Itong mga examples natin. So we'll reveal yung answers in the next slide. So here we go. Okay? So yung apat na octets kanina, okay? So let's switch back. Ito yun. Ito yung apat. 1, 2, 3, 4. Okay? So ito siya. So 1, 2, 3, 4. Okay? So ito actually yung kalalabasan nun. Okay? So for each octet, so 192.168, 10, and then 15. Okay? So yan yung isang buong IP address. And as you can see here, ito yung binary format niya. Okay? So ito yung pinaka in its raw form. And then ito yung decimal form niya. Okay? 192.168.10.15. Okay? So ganyan yan siya, ganyan yung itsura niya. Okay? So but obviously as humans, this is what we deal with, right? Itong decimal na to. Sila computers, ito yung how they deal with itong numbers na to. Okay? So that's because of yan yung language nila, right? Okay, so network and host portion. Okay? So importante to because ito yung parang nagbubuo ng isang IP address. It's broken down into two major parts. Okay, so yun yung network at saka yung host portion. So yung network portion, let's explain first is what is yung network, right? So we can say na yung devices or nodes connected to each other belonging to a certain group or location. Okay? And you'll see that a bit more later on, what we mean by that. Okay? Ang point is, multiple devices, right? They belong to a certain group, okay? Or perhaps even a certain location in the network, most likely. So yun. And the other thing is yung host part, okay? So ito yung nasa host part naman. Ito yung network portion kanina. Ito yung host. Okay? So a host is yung device or a node within that network, obviously. Okay? So they're identified on the network using IP addresses, which is itong kabuuang itong buong IP address na to. Okay? And the IP address has a portion indicating yung the network or yung group that the device belongs to. Ito nga yun. Diba? Ito yung pinag-usapan natin. And yung IP address also has a portion indicating yung unique identifier niya dun sa network na yun. So ito yun, yung host portion na pinag-uusapan natin. Okay? So yun yun. And then, so we move over dun sa couple of examples here, I guess. So yung makikita natin dito is yung few IP addresses that are part of the same network, meaning part of the same group. And as you can see, yun, so meron tayong 0, 1, and 2, right? So incrementing siya. So si .1 tsaka si .2, they're all part of this 192.168.10 na network. Okay? So yun yung kinalalabasan nun. Right, so let's explain why network and host ID. So baka tayo merong ganon. Okay? So as we can see, meron tayong network ID, which is ito, yung 192.168.1. Okay? Which, as we can see here, sort of points towards a certain group of computers or a certain location sa network. Okay? The same thing yung 192.168.2, which is nandito sa right side. Okay? So itong group na to, okay? Itong certain part of the network na to. Right? So it helps to point towards yung location nga nila ng isang particular network. Okay? And another thing is yung host, right? Yung host ID, itong .1, .2, and then .3. Okay? So it's identifying yung host on a particular network. So if yung network ID points to a particular network, yung host ID identifies each individual host within that network. Okay? So yun siya. So yun yung purpose nung dalawang yun. They work hand in hand. Right? And they make up yung whole IP address nga na tinatawag. So the key point here is yung dividing point between the network ID and the host ID. Okay? So ito yung dividing point na yan. Okay? Nakikita natin dito. So it's kind of similar dun sa phone number system. Okay? So, but obviously yung dividing point niya isn't fixed katulad ng phone number system. Di ba sa phone number system natin meron tayong tinatawag na area code tsaka meron yung local number. Okay? So parang ganun, may separation. So area code, of course, obviously points to a certain area, and then yung local number identifies or provides an address, kumbaga, dun sa sa phone line na yun, di ba? So another obvious thing here, if you can see, is it facilitates yung routing. Okay, so the thing to understand is that the way we do IP addressing has a lot to do with how we do routing. Okay. So, therefore, IP addressing and IP routing are tightly related. Okay? So, the fact na ginagamit nga ng mga routers yung network ID to route towards networks, right? And then, pagdating dun sa network na yon, yung host ID identifies each individual host within that particular network. So, you can see how this all works together, right? So, the nature is primarily location-based. Yun nga yung parang kinakalabasan na to. Kasi if you move a device, let's say itong computer na to over here sa kabila, kakailanganin mong palitan yung IP address niya. Okay? So yun yung kinalalabasan mo. Okay? Okay, so let's go to yung network and host example. Okay, so ito simple example lang. We have a couple of IP addresses here belonging to a certain network. Now, sa isang network kasi, we will have a network address. Okay? And yun yung pinakaunang IP address sa loob ng network na yun. So in this case, .0 yung pinakauna, right? And then yung pinakahuli would be a broadcast address. Okay? And we talked about broadcast before, right? And we know that ito yung ginagamit pag-communicate sa lahat ng host on a particular network. Okay? Send to all, kumbaga. Okay, so yan yung pinakalas yun. Okay? So hindi yan ginagamit, and as well as yung network address. However, everything between them is usable. So ito yung mga ginagamit yun, .1, .2, .3, .4, so on and so forth, hanggang 254, okay, bago dun sa broadcast address. So anything between the network address and the broadcast address in any particular network will be usable. Yun yung pwede mo i-assign sa computer mo. Okay? Or any host or even a router interface, right? Any interface running IP. Okay? So pag inassignan mo yun ng IP address, ang pwede mo i-assign din is yung mga usable addresses. Okay? So how do we identify what is the network and what is the host portion? Okay, so ito na. We'll go into the topic of yun na tawag natin subnet mask. But before we do that, let's identify muna kung ano yung subnet. Okay? So in simple terms, masasabi natin na isang subnet is kumbaga a smaller network within a bigger network. So kaya nga siya subnet, 'di ba? So, subnetwork siya. Okay? So, in this case, we have a big network which is 192.168.0.0/16. Okay? And you'll see bakit malaking network yan later, maybe. Okay? But ang point is, ang 192.168.1.0/24 tsaka yung 192.168.2.0/24, both fall under sa loob ng range nitong 192.168.0.0/16. Okay? So, this is a bigger range, itong /16 range na to. And itong dalawang /24 range na to is mas maliit. Okay? So, they both fall within sa range nito. Okay? So, therefore, pareho silang subnet ng 192.168.0.0/16. Okay? They are subnetworks. So, yun, we will try to define muna ano yung purpose ng subnet mask. Okay? So, one of the things is yung to help yung computers and network devices identify yung network and host portion. So, pinag-usapan natin kanina lang yung network and host portion. So, paano natin nasasabi kung asan yun? Asan yung dividing line na yun, di ba? Between the network and host portion. So, that actually is represented by yung subnet mask. Okay? And yung computers, since alam nila kung saan yung dividing point, di ba? Alin yung network part, alin yung host part. Malalaman nila din in turn kung aling network sila kasali. Okay? Which network do they belong? Okay? So this is to help, this is also to help yung routers identify which is the network portion, just like what we discussed earlier. Kasi di ba si routers ang tinitingnan niya aling network, yung certain IP address na nira-route niya. Okay? So, ang router is particularly only interested dun sa network part. Okay? Okay, for at least its basic functionality. Okay? So, yun. Given yung pagkaka-identify nga kung nasaan yung divide na yun between the network and host ID, sa part ng mga computers, it helps them identify kung part sila ng anong network. Okay? And then sa part ng routers, alin yung network portion, okay? Because that helps them in routing. Okay? So, if two computers are connected to each other, okay? Pero magkaiba sila ng subnet, okay? Okay, so let me back up a little bit. So, let's not say na connected talaga sila like physically, but I mean they're part of the same, let's say part of the same office, okay? Part of the same premise. Okay. However, they have different subnets, okay? So in this case, 192.168.1.0, 192.168.2.0, okay? So ito, si 2.2, tsaka si 1.2, okay? So yan yung dalawang example natin. Part sila ng dalawang magkaibang network and therefore, they won't be able to talk to each other, okay? By default. By default yun. Okay? So they'll only be able to talk to each other kung merong router in between them. Okay? So, yun yung purpose ng router na to sa gitna, to connect yung magkaibang networks, magkaibang subnet. Okay? So, magkaibang subnet sila, considered sila as magkaibang networks. So, ito talaga yung job ng router, right? So, to connect different networks together. Okay? So, ito na, let's discuss yung subnet mask, okay? So, we have an example here. Ang example natin is, it has a 24-bit mask. Okay? 24 bits yung naka-on. Okay? So, ang subnet mask uses binary din. Okay? So, zeros and ones din. And you'll see that here in example. So, ang example natin is yung 192.168.10.0 na network. Okay? So, since ang mask natin, subnet mask na gamitin natin is 24 bits. So, 8, 8, and 8. So, 8, 16, 24. Ang dividing line ng network and host portion is ito, dito, sa pang 24, right? Dito sa boundary. Okay? So, I wanna emphasize dun sa yung 24-bit mask kasi gagamitin natin siya sa examples in a bit. So, as we can see here, since dito yung dividing line, we have, ito, lahat ng zeros dito na natitira, right? And then, ito yung pwede natin galawin. Okay? So, meaning pwede natin yan i-flip yung mga zeros and ones dyan hanggang sa pwede siyang umabot ng lahat naka 1. And as you would know, based dun sa octet counting natin kanina, pag in-add mo lahat yan, yung 8, it will equal to 255, right? So, kaya nakalagay dyan 0 to 255 and it's a total of 256 values, possible values. Okay? 256 total addresses. Okay? Ayun, so ito is parang a chart in how to count in subnet masks, okay? So, if you remember, yung different positions kanina dun sa isang octet, okay? They're represented by 128, 64, 32, 16, 8, 4, 2, 1, right? So the thing is, yung subnet mask is from left to right lang, di ba? Depende kung ilang bits yung naka-on, yung sasakupin, right? Okay? So kung 24 bits, yun yung sasakupin niyang lahat ng bits dun sa isang group ng 32 bits. Okay? So yung counting nun would be based on how many yung bits na naka-on from left to right. Okay? So we have here, ina-add lang natin siya. So as you can see, 128, for example, if we start sa position ng, okay, kunwari lang. So let's say, nandito yung pang 24th bit. Okay? Ito is pang 25, 26, pang 27, 28, 29, 30, 31, 32. Okay? Hanggang sa katapusan, right? So kung ang mask is hanggang dito lang, okay? Hindi siya umabot dun sa pang 25. So 0 pa yan, right? Dot 0. Ngayon, pag ang mask is, let's say, 25 bits long, okay? Ibig sabihin hanggang dito na siya sa position na to. So hanggang dyan, yung dividing line. So 128 siya, okay? So dot 128. Ngayon, kung hanggang dito siya, hanggang sampang 26 siya, 26 bit. So, ibig sabihin 26-bit mask. So, 128 plus 64, yan, nakikita nyo, 128 plus 64 equals 192. Okay, so kung 26 bits yung mask, okay, ibig sabihin 25, 26, 27, sorry, did I say 26? Yeah, 27, I mean 27. So, yun, i-add lang natin uli, 128 plus 64 plus 32. So, ito yun, 128 plus 64 plus 32. So, 224 siya. Okay? So yan yung mga possible values na makikita nyo sa lahat ng subnet mask. 128, 192, 224, 240, 248, 252, 254, 255. Okay, so you'll see that later on. Okay, so dito na, let's go into some subnet mask examples. In fact, medyo na-discuss na natin siya kanina. So makikita nyo dito, diba? So let's say we have two examples here. 192.168.10.0 na 25-bit mask, and we have another 192.168.10.0 with a 26-bit mask. Okay? So in this case dito, 25-bit mask, hanggang dito tayo yung dividing line natin. Okay? And if you remember, ang position is dito sa pinaka leftmost part is 128, right? Di ba 128, 64, 32, 16, 8, 4, 2, 1 yan, right? Di ba? So since hanggang 1 lang yung naka-on dito, di ba? So 8, 16, 24 plus ito yung nag-iisa dito, 25. So 25-bit mask ang gamit. 25-bit siya kahaba. 128 yan dito, di ba? So of course, lahat ng mga dito, yung mga nauna, populated sila lahat, di ba? So ano na yan, it's a no-brainer. Puro 255 lahat yan. Right? So, yan yung mga makikita nyo laging subnet mask. 25, 25, 25. Tapos, yung pinakadulo is yung magiging sort of variable siya depending kung hanggang ilan yung mask. Okay? So, kung hanggang dyan lang yan, 24, okay? 0 tong isang to. 0 yan. Okay? So, dito tayo sa 26-bit mask, okay? So, 8, 16, 24, 25, 26, okay? So, may additional 1 compared kanina. So, obviously, lahat yan, 255, 255, 255, hanggang dito, which is, ang alam natin, position niya is 128 plus 64, so 192 yan. Okay? So, ganun siya. Okay, so we now discuss yung network address and broadcast address. Okay? So, na-tackles natin siya kanina a little bit. Okay? So, let's just use yung ano natin, example natin na merong 24-bit mask. So, in this case, ang pinakaunang address sa network na to is 0, pinakahuli is 25. Okay? Similar lang yung sa kanina. So, yung network address represents yung the whole network. Okay? So, yan yun. So, if we want to kumbaga specify kung ano yung network, okay? Network yung buong network, we just specify yung network address niya plus yung mask. Okay? Hindi ko lang in-include yung mask kanina dito. But that's really the point here. Yung pinakauna, yung network address, yun yung magre-represent sa buong network. Okay? Ngayon, kung ano yung range ng network na yun will be provided by yung subnet mask na ginagamit. Okay? So, yun yung. Yun lang yun. Identify lang natin kung ano yung network address. Ngayon, hindi ito ina-assign. Okay? So, huwag ina-assign to. Then, yung broadcast address is yung yun nga, yung used to communicate sa lahat ng host. Okay? So, send to all. Okay? Hindi rin ina-assign to. Okay? Yun yun. So, everything in between is usable. Okay, so let's go into yung tinatawag natin na prefix length. So, yung prefix length, it's considered as a subnet mask shorthand. Okay? So, paano nangyari yun? Okay, so ganito kasi. Yung, explain muna natin what a prefix is. Yung prefix kasi is a typical alternate name for a network address. Okay? So, yun. Yung kanina pa natin sinasabi na network address, right? Now, yung prefix length, siya yung ilan yung subnet mask bits. Okay? So, yung term natin kanina, 25 bits, yung subnet mask and all that. So, yun yung prefix length. Okay? Okay, so yun. If we say 25 bits yung mask, okay, so ibig sabihin ang subnet mask nun is 255, 255, 255, 128. Kadalasan we don't really want to specify itong mahabang na to, subnet mask na to. So, usually ang sasabihin natin is 192.168.10.0/25. Okay, so ito yung ginagamit ko kaninang connotation, di ba? Kanina pinag-uusapan natin yung subnets. So yun, sa /25. So ganito rin dito, 192.168.10.0 and then 26-bit mask siya, so /26. Okay? So, pwede kang sabihin /26 lang siya. Okay? So shorthand siya, imbis na isulat ko yung 255, 255, 255, 192. Ang haba nun, di ba? Okay? So, understood na yun. Pag sinabi yung /25, /26, understood yun if you're talking to other engineers, ganyan. Yun yung terminology. Okay? Okay, so let's go into yung IP address classes. Okay? So, let's go through yung IPv4 range ng mga classes. Okay? So, we have here yung class A, B, C, and D. I'm not expecting you to nakabisaduhin to agad right away, and you don't necessarily have to at this time, okay? We'll go through a little bit more of discussion bago nyo fully maintindihan itong mga range na to. So, yun lang, specify ko lang dito na yung class A is from 0 to 127. Okay, so primarily ang tinitingnan natin dito is yung first octet. Kung mapapansin nyo siya, 0 to 127, 128 to 191, 192 to 223. Okay? Sorry, nilagpasan ko yung class B. Class B as 128, 191. Class C is 192.223, and then Class D would be 224.2239. Okay? So, yung the rest nito is hindi nagamit. Okay? So, kaya hanggang Class D lang ako. And in fact, yung Class D is used for special reasons. Okay? So, normally, Class A, B, C lang tayo. Okay? Yeah, so yung Class D is used for multicast. Okay, so let's go into yung IP address class binary. Okay? So, para maintindihan natin yung mga range kanina, kailangan natin i-open up kung ano yung talagang underlying equivalent into binary nung nitong mga range na to, ng mga different classes, okay? Classes of IPv4 addresses. So, sa class A kasi, ang leading bit is laging 0, okay? So, hindi pwedeng galawin yan. Kumbaga, as a rule, okay, class A is leading bit is laging 0, okay? So, pwedeng mabago yung the rest, okay, nung first octet, pero hindi pwede mabago yung pinaka-umpisa. So, kung fix yan, and then the rest is, depende, pwedeng mag-turn on lahat ng to, okay? So, ibig sabihin, ang maximum value nito is 0 and then 7 1. So, itong 7 1 na to, pag in-add mo to, is actually equal to 127. So, that's why ang range niya is 0 to 127. Okay? So, let's go to class B. So, si class B, ang leading bits niya, ang required is 1 and 0. So, hindi pwedeng mabago yan. Fix yan. So, laging 1 and 0 yung leading bits. The rest, pwede yan magbago. Okay, so pag na-hit natin yung maximum possible value nito, yung number nito, which is ibig sabihin, naka-on lahat, naka-1 lahat. So, 1, 0, and then 6 na 1 is equals to 191. Okay? And as you can see here, 1, 0, and the rest is 0, right? Alam natin no 128 yung position nito. 128, 64, 32, if you remember, right? So, 128 siya. So, 128 dito. 128 to 191. Okay? So, yung equivalent lang nung lahat ng bits na naka-turn on. Okay? With the restriction of yung rule na kung ano yung kailangan na leading bits. So, in this case, class B is 1, 0 palagi. Class C is 1, 1, 0 yung leading bits. So, we can see that here, 1, 1, 0, 1, 1, 1, 0. Okay, so the rest can be changed. Okay, so in this case, 1, 1, 0 and the rest is 0. And then maximum value niya is 1, 1, 0 and the rest is 1, 1, 1. Ang equivalent nun is 192. So remember, 128 plus 64, right? So 192 siya. Dito, and pag in-add mo, add up mo lahat yan, 128, 64, 16, 8, 4, 2, 1, 2, 2, 3 yan. Okay? So, ganoon. Yun yung equivalent sa binary. So, kaya ganyan siya. Alright? Okay. So, let's see. Let's move on to our next slide. So, yun. Why classes? Okay? Ano yung reason baka tayo may mga classes? Kasi, nung early days, nung internet, we wanted to have a way to allocate IP addresses based on yung size of the network, okay? So, that's why we had yung tatawag nating class A, B, and C, okay? So, we can say na, kasi sa class A, okay? Ang class A is, tawag nito, ang pag-consider natin sa class A is, ang network bits niya is 8 bits, okay? Sa class B is, ang network bits niya is 16, okay? So remember, ito yung subnet mask bits, okay? 1, and then 2. 1 octet yung haba niya dito, 2 octets dito. Then sa class C is 24, diba? 8, 16, 24, okay? So yan yung pinaka-network portion. So makikita nyo dito, network and host portion, network and host portion, network and host portion. So pagdating sa class A, konti yung networks, marami yung host. Class B, pantay lang yung number ng networks tsaka number ng host. Pagdating sa class C, maraming networks and maraming host. Okay, sorry, may slight problem dito, umusog. But anyway, ang point is, pwede natin ito i-consider as parang small, medium, large. Okay? So let's just say na ganun. So small, kung gusto mo, if you have a smaller requirement for network, small, and then medium, and then large. Ito, pagdating dun sa um, class A, pinakamalaki. Right? So routing also had to work with this scheme. Okay? So of course, kailangan because they work hand in hand, right? Hence yung tinatawag natin na leading bits. Okay? Kaya yung A, sinabi natin, leading bit niya is 0. That's kumbaga, for us, ang isip natin is class A yun, right? And then another thing from the perspective ng routers, ang tingin niya is 8 network bits yun. Okay? So, ganun din sa class B, leading bits 1 and 0, 16 network bits. Okay, ganito. And then class C, leading bits 110, and then yung network bits niya is 24 bits long. Okay? So, itong leading bits na to is of course also equivalent dun sa IP address ranges that we just discussed dun sa previous slide. Okay? Ito. Okay? So, it's exactly the same thing that we're talking about here. Okay? So, yun. So, this approach to addressing and routing is called yung classful addressing tsaka classful routing. Okay? So, remember, classful. Okay? As you can see, yung divide between the networks, network bits are always at the octet boundaries. So, laging dito, yung pang 8, pang 16, pang 24, right? Laging na dun sa boundary ng octets. Okay? So, it's been a long time since nag-move away tayo from this approach. Hindi na to ginagamit actually. Today, ang ginagamit natin is yung classless addressing and classless routing. Okay? So, classless na tayo. Wala nang classful. Okay? So, the scheme wherein we have yung certain classes or range of IP addresses is obsolete. Okay? Wala na yun. Yung meron tayong certain classes and then IP address range within those classes, okay? So, however, we still use some of the terminologies today. Let's say, for example, class A mask is 8-bit mask, class B mask, 16-bit mask yun. And if we say class C mask, that's 24-bit mask, okay? So, ginagamit pa rin natin yung terminologies na yun, okay? Because it's been well known na all across lahat. Nasanay na tayo doon. Ngayon, yung tatawag natin na private addresses, okay, which we'll talk about in a bit, use yung IP addresses within this traditional class A, B, and C na range, okay? So, these are the reasons bakit important pa rin siya na discussion, okay? So, we'll get into that para makita nyo. Okay, so let's go into yung sample allocations muna, okay? Given nga it's kind of equivalent to small, medium, large, pinag-usapan natin kanina. So if we're talking about class A, since we have 8 network bits, it gives us 16 million plus na host addresses, okay? So imagine kung gano'ng karami yan, okay? So kaya yun, pang large network siya, kumbaga. So class B, 16 bits yung haba ng network bits niya. So 65K, 65,000. Okay. And then class C /24 mask. So 24 bits long yung subnet mask niya, 256 total addresses lang yun nandito. Okay. So yun. Nakita nyo kung paano, gano'ng karami yung possible na host, di ba? So yun yung nagagamit for an example. Okay, so let's go and discuss yung tatawag natin na public versus private addresses. Okay, so sa IPv4 address space kasi, yung lahat-lahat ng IP addresses na pinag-usapan natin up until now, nahati yun in a different way, which is yung tatawag natin na public and private addresses. Okay, so ginawa to to save IP address space and prevent exhaustion. Okay, kasi yung tawag dito, there's been some sort of misuse or misallocation ng mga IPv4 addresses mula pa nung unang panahon. Okay? So, hindi naman natin inaakala na mag-explode yung internet, dadami yung mga connect sa internet, and therefore, kakailanganin natin na mas maraming IP addresses. And kaya nga rin na invento yung tatawag ng IPv6, okay, na-discuss natin nakaraan. So, kaya ganun, okay? So, isa sa mga ways na, kumbaga, to prolong the life ng IPv4 address space is yung paghati nito into public and private. Okay? So, only public addresses are routed in the internet, okay? So, by policy yon, not by technical reasons, okay? So, ibig sabihin, yung mga internet service provider lang yung nag-implement nun in their policies, yung mga sa configuration ng networks nila, yung mga routers. Okay? So, but technically, an IP address is an IP address, and you can talk between public and private addresses if you will, if sa loob lang ng sarili mo lang network. But across the internet, that wouldn't work, okay? So, ibablock ka ng ISP mo kung naka-private address ka. So, public addresses lang ang nararoute across the internet. Okay? So, this is to hide yung private addresses from the public. So, if you're going to assign IP addresses sa loob ng network mo, you're free to use yung private address range in any way you want, okay? But yung public IP addresses mo needs to be unique sa all across the internet, okay? Yung private addresses mo, hindi na yan dapat nakikita ng internet. You can do whatever you want dyan, okay? So meaning yung private address range na to can be repeated in different organizations, no? So, company A may use yung certain private address range, and then company B may use the same one, and obviously, hindi naman nila kailangan magkakitaan. Okay? So, it's okay. Private IP address range naman sila. So, here we go dun sa private address range. Okay? So, we have yung tinatawag natin na class A, B, and C pa rin. Okay? And as you can see, pareho pa rin yung number ng network bits, 8. Sorry, hindi pala pareho, but I mean, it's, tawag dito, close dun sa range na, na sasakupin nitong private addresses na to, di ba? So, before kasi, if maalala nyo, nag-start tayo sa 8, di ba? Yung class A. So, it remains the same dito. So, hanggang, pa rin siya, itong second, third, and fourth octet pa rin yung sakop niya. Meaning, it gives us yung 16 million addresses na possible sa isang class A address. Okay? Now, pagdating naman dun sa class B, okay? So, remember, yung class B is, kanina, is hanggang dito, right? But here, in yung private addresses, humugot tayo ng, yung 4 bits dun sa network part, okay? Para maging range nung class B. Okay? So meaning, the class B will be able to provide us with this many network ranges, 4 bits worth of network range 2 raised to 4, okay? Okay? Na number of networks, or let's say subnets. And then within those subnets na yon will have yung the same 16 bits pa rin. Okay? So, kaya ganyan yan. Makikita nyo. Okay? So, 2 times 2, 4 times 2, 8 times 2, 16. So, makikita nyo dito 172.16 hanggang 172.31 yung range. So, that's actually 16 possible values, right? Which equal siya talaga dito sa 4 bits na to. So, yun yung range niya. So, 172.16.00, yung pinaka-umpisa sa 172.16. Hanggang sa 172.31 and 255, all 255s dun sa pinaka-dulo ng range. Okay, so we go to, class C. Okay? So, 192.168.0.0 hanggang 192.168.25255. So, remember, yung class C natin is dito, yung traditional class B mask natin is dito, di ba? So, makikita nyo humugot siya ng isang buong octet. Right? So, isang buong octet niyan, meaning 0 to 255 yan. Okay? So, 256 total subnets, kumbaga, networks. So, 0 to 255. And each one of them is another 0 and 255. Okay? Yun. So, ganun yung kalalabasan niya. So yan yung private address range. You're free to use this just within your network, okay? So, hindi to, however, gagana paglabas na ng internet. Okay, so let's go into questions. If there are any questions before we proceed doon sa susunod nating gagawin, which is yung lab demo. Any questions? Okay, so if there are no questions, you can still buffer it later on. I will proceed siguro dun sa ating lab demo. Okay? So, for our lab demo, meron akong topology dito, which I'm going to discuss first a little bit before we go into our lab demo. So, I'll share it with you. Okay? So, yan siya. So, discuss ko muna yung gagawin natin. Okay? Okay, so dito sa ating lab demo, okay, yan, so we have our 3 routers, okay, BSRX1, 2, and 3, okay. And then, ang gagawin natin is assignan natin ng IP addresses yung bawat segments between them, okay, para makapag-usap-usap sila. So, we'll start with a blank configuration sa IP address configuration. So, ano siya? Tawag dito, wala siyang naka-assign na IP addresses. A-assignan pa lang natin siya. Okay? So, in this case, I will do a simple allocation. Okay? Para ano lang to, tatlong class C na network. Okay? Assignan natin siya. So, 1, 2, and 3. Okay? So, 1099.12 dito, between BSRX1 and BSRX2. 1099.13 between BSRX1 and BSRX3. And then finally, 1099.23 between BSRX2 and BSRX3. Okay? So I can keep that sa separate window while we're going through yung lab demo. So I don't have to keep switching back and forth. Okay? I'll go through yung explanation ko from the command line dun sa routers natin. Okay? So let me switch my screen dun sa ating console. Okay? So yun siya. We'll start at BSRX1. Okay? So sa BSRX1, we have two... so sa lahat ng router, we have two interfaces to configure. Okay? Each of them facing to the other two routers na katapat nila. So in this case, kay BSRX1, we're going to configure two interfaces, 001 and 002. Okay? So, ito siya, 001, 002. And as you can see, wala siyang naka-assign na IP address. Okay? 001 and 002. Okay? Yan, so let's just configure them. So, pinakauna si 001 muna, which is dapat nasa 1099.12.network siya and siya yung naka-assign sa .1 na host ID. Right? So, set interfaces. Okay, so let me show muna yung Okay? So, nandiyan siya pero wala pa siyang IP address. Okay? Unit 0 family inet 1099.12.1. .1 siya dapat. /24. Sorry. Forgot the inet address. Okay? Yan. So, another thing is yung 002. So, kailangan din natin siya i-assignan ng IP address. 1099.13, right? And then .1 din siya, /24. Okay. Okay, so now we have that. We can commit this configuration. Okay, so at this point, wala pa tayong makakausap nito dahil hindi pa naka-configure yung the other end of these segments, no? Okay, so purely sa side pa lang ng VSRX1 yung na-configure natin. So let's hop on to VSRX2. So in this case, VSRX2 is yung katapat nito, yung 1099.12.2. So let's go with that first. Okay? So VSRX2 katapat niya 002. No? Sa katapat ng VSRX1. So let's look at that. So nasa 02 siya. Okay? Sa VSRX2. Siya yung 12.2 dapat. Yun, okay. So, oops. So, 002. Okay. 1099.12.2. Okay. So, let's see. Unahin muna natin ito i-configure, then we'll validate it. Let's see if it works. And so, we'll ping this from VSRX1. Okay. Yun, so, it's working, right? So, may communication na si VSRX1 and VSRX2. IP communication. We'll just let's try to configure VSRX3 first, okay? From router 1's perspective, di ba? So dito, para may kausap siya dito. Buuin na natin to, yung 1099.13.1 na to. So yung kabila nito is 1099.13.3. Okay? So let's see. Show interfaces. GE. Oops. And then sa VSRX3, ang katapat ni VSRX1 would be 001. Okay. So let's try to set that. Oops, sorry. 1099.13.3/24. Okay. Let's commit that, and then we'll try to ping from VSRX1. Oops, let's wait. Okay, committed na siya. Alright, so it's working. So, one last segment na lang, yung between VSRX2 and VSRX3. Okay? And that would be 001 kay VSRX2. Siya yung 1099.23 network. .2 siya. So, let's see yung existing interface niya. 001. 001. Oops. Okay. 1099.23.2/24. Okay? So, configured na yan, and we'll have to configure the other end for it to work. So, show interface. Let's see. Ano yung kay VSRX3? 002. Okay. Configuration. Ten 1099.23.3/24. Okay. So let's see. Wait. Let's try to ping this from VSRX2. Kailangan reachable na siya from VSRX2. And there you go. So we've completed yung lahat nung allocation, pag-assign ng IP address sa lahat nung router interfaces natin. Okay? Lahat ng segments, yung tatlong segments. So we have 3 networks na na-configure. Okay? So 3 different network segments connected by 3 different routers. Okay? So yun siya. Yun lang for this demo. We'll have another one sa susunod. Okay? We'll go back to our discussion and see what's wrong about dun sa ginawa natin ngayon lang. Okay? So, let me switch to the next set of slides. Okay, so here we go, right? So, what's the problem? Okay, ano ba yung problem sa ginawa natin so far, di ba? Well, okay, well, technically hindi siya, of course, mag-cause ng issue. The thing is, yung problem natin, yung problem ng allocating networks with excess usable IP addresses, okay? So, the IP addressing exercise na ginawa pa lang natin is not something you would really do in the real world. Of course, hindi ka pwede mag-waste ng isang buong class C na network which has 254 usable hosts minus yung network tsaka broadcast address on a network na kailangan lang ng dalawang addresses lang, di ba? Ang kabilaan lang yun dalawa lang yung ginamit natin, di ba? So, but the point is, we just wasted yun nga, a lot of IP addresses and wasting a lot of IP addresses like itong pinakita ko sa inyo ngayon, happened a lot in the old days, okay? So, yung solution would be, mali pala yung slide ko ata. Sorry. Yung solution would be yung tinatawag natin na subnetting. Okay? So, we've talked about subnets before, di ba? And now, ang pag-usapan na natin yung tinatawag na subnetting. Okay? So, paano ba natin na-achieve yung different subnets na yun? So, ang ibig sabihin lang, syempre, is yung pag-breakdown nga ng network into smaller subnetworks like we have discussed earlier, di ba? So, if you would notice, the word subnet now really makes sense, right? Okay? So, it will make more sense pag pinakita ko sa inyo yung paano ba natin ginagawa yung subnetting, okay? So, let's go back to our IP allocation. So, we have we've been using yung example natin na 192.168.10 ever since kanina pa, umpisa, di ba? /24. So, this gives us 0 to 255, di ba? Na possible values, 256 in total possible values. Okay? So, yun. That's what we have at the moment. Okay? So, identifying how many usable IP addresses na kailangan lang talaga natin. Okay? So, yun, how many do we need? Okay? So, remember, to identify how many hosts are available para sa atin, kailangan natin i-figure out using yung subnet mask. Right? So if you remember kanina, yung nagdi-dictate nung separating line between the network ID tsaka yung host ID is yung subnet mask, right? And therefore, it also tells us how many hosts are possible based on sa ano na yon, sa subnet mask na yon, right? So let's say kung 24-bit mask ka, ibig sabihin yung natitira sa kanan, right, na host, yung host portion, ano yun, 256 total possible values yun, 0 to 255. Okay? So in the same manner, in the same approach, gagamitin din natin yon sa pag-determine ng correct na subnet mask for subnetting. Okay? So this means we need to know ano yung subnet mask na gagamitin natin to get us yung number of hosts na kailangan natin. Okay? So this is same thing as saying how many bits we need to get us the number of hosts we need. Okay? So we'll go back to yung ating binary discussion before, di ba? So 2 usable IP addresses and of course, there will be by default isang network tsaka isang broadcast. Okay? So to get itong total na to, 2 plus 1 network plus 1 broadcast, so 4, di ba? So to get 4 IP addresses on each link, okay, on each segment, can anybody guess how many bits it will take? Ilang bits yung most likely kakailanganin? Any guesses? Okay, so sa next slide natin, we'll try to identify kung ilan, okay? So eto, let's go through it, okay? So in binary, binary again, okay? So huwag kayong ba masyadong malungkot pag nakita kayo ng binary. Required talaga to. Okay, so para makuha nyo yung pinaka-basics. So part to ng part to ng fundamentals, okay? So binary is dito yung /24 natin, di ba? So we have 0 to 255 kung ang pagbabasihan natin is yung ito yung subnet mask /24. Ito yung original natin. This is what we have at the moment, right? Ngayon kung isa-subnet mask natin siya, isa-subnet natin siya and kailangan lang natin ng 4 IP addresses, meaning dalawang usable lang at each segment in each network, most likely we will only need we will only need 2 bits sa host portion. So paano nangyayari yung 2 bits lang? Okay? So 2 bits, di ba? 2 raised to 2. Diba? So 4. Right? So 4 possible values yun. Okay? So yun lang yung kailangan natin. So 4, yung una doon is network, yung huli doon is broadcast. Yung matitirang gitna ng dalawa, yun yung gagamitin natin. So pag ginamit natin yun, ang mangyayari is 0 to 3, di ba? So 0, 1, 2, 3, so 4 yun. And then 4 to 7, 4, 5, 6, 7, so 4 uli yun. So kung kada subnet is 4 na IP addresses. Okay? And as we can see here, kung 2 bits lang yung network, ay yung host ID natin, ibig sabihin, ang network part natin is hanggang dito, pang 30-bit mask. Okay? So, we'll only leave 2 bits para sa hosts. Kakainin ng buong network portion yung hanggang 30 bits. Okay? So, /30. And also, yung subnet mask natin will be 255, 255, 255, 252. Okay? So, 128 plus 64 plus 32 plus 16 plus 8 plus 4, okay? Hanggang dyan lang, hanggang 4 lang, is 252. So, kaya ganyan siya. Okay? So, let's see that dito sa first subnet natin. First subnet natin is ito, using /30 mask. Again, 0 to 3 yung kanina, di ba? So, 0, 1, 2, 3, right? So, as you can see, yung pinakauna is, of course, 00. Di ba? Wala pang nagbabago eh. So, yan yung magiging network address natin. Now we will try to increment that. So 0, 1. So 0, 1 will be yung first usable natin. Okay? So saying that 1. And then pagka in-increment uli natin, of course, 1 na yan. Ibig sabihin, mag-i-increment yung susunod sa kanya. And then mag-switch back siya to 0. So 1 na to, 0 na to. Okay? So from 0, 1, it becomes 1, 0. Okay? And then obviously, 1, 0 means 2. Okay? So yan yung second usable natin. And last usable, in fact. Dahil hanggang dito lang tayo. Okay? So 1, 0, if you increment that again, is 1, 1. Okay? So 1, 1 is equals to, diba, 2 plus 1. So 3 yan. Diba? So yan yung broadcast. Yan yung pinaka-last. Okay? Pinaka-last, so ito yung maximum value na pwede natin ma-achieve sa subnet na to. Diba? All ones na siya. Diba? Kung makikita nyo dyan. Okay? So let's go to our second subnet kung makikita nyo. So in binary again. Okay, yung IP address natin sa second subnet. Notice how the network portion incremented, okay? And na-reset yung host portion. So as you can see here, reset tayo, 0, 0. Balik tayo sa pinakaunang value, pero nag-increment na tayo sa network portion, right? Yung ito, yung sa side ng network, di ba? Okay, so yun. So, remember, 1, 2, 4, di ba? Yung value niya, 1, 2, 4, 8 yan, di ba? So, nasa position 4, naka-on siya. So, 4 yan, di ba? And this is our network address. Okay? So, ito. So, without moving yung sa network side, so, increment 0, 1 siya. So, 4, 0, 1, right? So, ang position nito is 4, 2, 1. So, naka-off yung 2 sa gitna. So, 4 plus 1 lang. So, 5, di ba? Yan yung first usable natin. And then, we go to yung susunod. So, ganun pa rin. Yung network portion remains the same. But we increment 0 from 0, 1, we go to 1, 0. Okay? So, increment yung susunod sa left side ng 0 and then reset yung 0 sa dulo. So, remember, 4, 2, 1. Ito yung value nito, di ba? Or 1, 2, 4. Kung pagbabasihan natin yung pagbilang natin kanina, right to left. So, 4 plus 2 is equals to 6, right? So, yun. So, yun yung susunod na usable natin. And obviously, again, yung pagka na-reach na yung maximum range, which is from 1, 0, increment ulit, 1, 1 na siya. Okay? So, pag in-add mo lahat yan, 1, 2, 4, diba? So, 4 plus 2 plus 1 equals 7. Okay? Which gives us yung broadcast address natin. So, I hope you're getting the flow here kung paano siya gumagana. Okay? So, this will happen so on and so forth. Okay? Hanggang sa yung mga susunod na subnet dito. But we won't really get into that anymore. I think enough na example natin. Okay? So, let's go to in decimal. Okay? So, ito yung easy way. Okay? So, dito kasi iintindihin nyo lang yung parang lumalabas na pattern niya. Okay? So, ito yung, gagamitin natin na, kumbaga parang, cheat sheet. Somehow, okay? So, in decimal kasi, di ba? Tawag dito, kanina ang habol natin is 4 usable addresses, right? Sa isang subnet. Okay? So, actually, pwede natin gamitin yung values ng each position kanina. Remember yung octet? Yung 1, 2, 3, 4, 5, 6, 7, 8, right? Yung isang octet natin. Di ba yung position niya, 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. Yung position niya na yun, we can actually double as yung number of IP addresses per block. Okay? So if we're looking for IP addresses per subnet, okay, or per block of IP addresses, we can use yung katapat niya kaagad, okay? Dun sa subnet mask counting, di ba? So remember yung subnet mask counting natin, di ba? Pag in-add mo yung 128 plus 64, di ba? 192 yon. 128 plus 64 plus 32, 224 yon. 128 plus 64 plus 32 plus 16, 240 yon. So on and so forth, right? So lahat yan, ito, may mga corresponding na yun na, na values na katapat. 128, 192, 224, 240, 248, 252, 254 hanggang sa 255 siya, di ba? Pag in-add mo nga to lahat, right? So yung katapat na itong 4 na to, dito, okay, sa position niya, yun na yung subnet mask mo. Okay? So kung naka/30 tayo, di ba? So remember, /30 is, pag binilang natin dito sa ito, yung lumalabas ito yung last octet, di ba? So bago 'yan 24, di ba? So 25, 26, 27, 28, 29, 30. Okay? So sakto siya, di ba? 30 siya. /30 dito. Okay? So /31, /32 na to. So hanggang dito lang tayo, di ba? So sakto siya, apat yung kayang ibigay sa atin na IP addresses nito pag /30. And also, nandito na rin yung 252 na gagamitin natin dun sa subnet mask niya. So, you can see /30, block of 4, and then .252 siya. Okay? So, ayan na. Nakikita niyo na yung shortcut, di ba? Okay. So, now that we know how much yung usable IP addresses na kailangan natin, how do we make this happen? Okay? So, let's go to our next slide. Okay? So, identifying the network portion. Okay? So, discuss muna natin to. So, it's easy. You already know yung host portion. So, you automatically know yung network portion, right? So, in our case, we're more focused on getting yung number of, yung required hosts. Okay? Number of required hosts. So, we didn't really care too much about yung the number of subnets. Okay? So, if the number of subnets were a priority, mangyari lang is then we would have tried to identify yung network portion first, okay? But in this case, ang target natin is yung number of hosts, di ba? Kasi kailangan lang natin 4 per segment, okay? Per subnet. So now we know which subnet mask to use, okay? Diba? So makikita nyo dito, so from our original network, di ba? 192.168, di ba? Yung subnet mask niya is /24. So 2 raised to 8 is 256 to total possible values. In this case dito, yung sinabnet na natin siya hanggang /30 lang tayo, di ba? So ang host natin is 2 raised to 2 dito sa host portion. So 4 possible IP addresses yun. So in the same way, yung binarrow natin na tawag dito, yung magiging number of subnets natin all within under nung bigger /24 range natin, di ba? Is itong 6 bits kung saan tayo nag-move, di ba? Kasi kanina /24 tayo, nandito tayo, di ba? So nag-move tayo to the right, okay? So kinain natin tong 6 na bits na to para to achieve yung target natin na 4 IP addresses lang sa isang subnet. Okay? So 4 hosts lang. So meaning kumain tayo ng 1, 2, 3, 4, 5, 6 na hosts. Na bits, okay? Okay, so ito yung mangyayari, ito yung magiging possible number of subnets natin. So 2 raised to 6 is equals to 64. 64 total possible subnets natin. In each of them would have 4 total possible host IP addresses. Okay? So if binilang mo to, 64 subnets times 4 hosts is equals to 256 IP addresses in total. Okay? So we're in exactly this sa loob ng same range nung original /24 natin. Only that pinaghati-hati natin siya. Okay? So break apart natin siya into 64 subnets, each having 4 hosts. Okay? Yun. So now we know ano nga yung subnet mask natin na gagamitin natin. Right? So 255.255.252. Okay? We know how many subnets we have, 64. We know how many addresses per subnet we have, which is 4. Okay? Yun. So let's go to our subnetting cheat sheet. Okay? So in this example, we use yung fourth and last octet, right? So as we've been using all this time, right? So from left to right nga is yung 128, 128, ano ba? Right to left, sorry.
Ito ako dun. So, from right to left, 1 to 128, diba? Ito yung mga meaning ng bawat position kanina, yung number niya, diba? So, again, this doubles for yung usable blocks, diba? So, yung example natin kanina is usable IP addresses for each block is 4, diba? Kasi naka/30 tayo. And of course, yung subnet mask natin, .252. Okay? So remember, yun nga, when we use yung .252 kanina, we did that because we needed a block of 4 IP addresses. Okay? Okay? So, another thing is yung dito, yung from left to right. Okay? So, galing tayo sa /24 kung 0 lang yan. But if we move to the right, so we get 25, 26, /27, /28, hanggang /32. Okay? So, yun. So, if we were using /24, we would be able to utilize all of these bits for yung host. That means 256 IP addresses, right? If you remember. So, and again, yung subnet mask counting natin, di ba? So, 128 plus 64 equals 192. 128 plus 64 plus 32 equals 224. So on and so forth, right? Hanggang 255. Pag in-add mo lahat yan, okay? Ibig sabihin, pag sinakop mo lahat to, kung naka/32 ka, ibig sabihin, .255 tayo dito sa ating subnet mask. Okay? So yan yung subnetting cheat sheet, okay? Pwede nyo kopyahin yan. Simple lang naman siya, madali lang siya. Actually, ang mangyayari is masasaulo nyo yan over time. Okay? And you don't really need to, hindi mo kailangan ng scratch paper para mag-compute or calculator. Magkakaroon ka ng subnetting calculator sa utak mo. Okay? So, ganyan yung mangyayari nun kapag nahasa kayo. Alright, so, ito yung review lang natin yung IP allocation details natin. Okay? So, ang target natin would be yung required subnets, number of required subnets, number of required hosts per subnet, which is ito yung actually habol natin kanina, and then yung subnet mask to be used. Okay? So, yan. Nakuha na natin lahat yan. Okay? We already have all this information. Okay? So, breakdown na natin ulit. Ito, na-discuss na natin to kanina. But ito, 64 times 4, di ba? 64 subnet times 4. All in all, 256 IP addresses pa rin siya. Okay? So, ang reality is kailangan lang talaga natin ng 3 subnets. Okay? So, kasi 3 lang naman yung segments natin. Okay? But indeed, we need 4 required hosts per subnets. Okay? And then yung subnet mask to be used natin is ito. As we all know, 255.255.252. Okay? So, that's it. We have itong lahat ng 3 subnet na gagamitin natin. So again, 0 to 3. Okay? So review lang natin. And then 4 to 7. Okay? And then 8 to 11. So take note, all of these subnets are represented by their network address. So 192.168.10.0/30 is yung first subnet. 192.168.10.4/30 is yung second subnet. And 192.168.10.8/30 is yung third subnet. Okay? So they're all represented by their respective network addresses. And because of their range, depicted by yung prefix length or yung subnet mask, so 30-bit mask siya. So in this case, ang mangyayari ito 0 to 3, 4 to 7, 8 to 11. Okay? So 4 IP addresses per subnet. And therefore, 2 usable IP addresses per subnet. Okay? So minus the network and the broadcast. Okay? Per subnet yun. Alright, game. So let's go to our final lab demo. Okay? So we'll go through yung same topology pa rin, but we'll do a renumbering of our IP addresses. Babaguhin natin yung ginawa natin kanina kasi waste of IP addresses yun. And we'll use yung ating ito, yung 192.168.10 network. Okay? Yung 3 subnets natin na ginamitan natin ng subnetting. Alright? So it's the same diagram. You already have yung diagram that I've shared earlier. So refer na lang kayo doon ulit. I'll switch to my console into the routers and we'll go into yung configuration. Okay? So let me share my console screen again. All right. Okay, so we have yung ating original configuration kanina, which is gumagamit tayo ng class C network per segment, which is a total waste of IP addresses. So papalitan na lang natin siya nung yung ginawa nating subnetting. Okay, yung 192.168.10.network na tatlong /30. Okay? So let's view yung existing configuration. Okay. So view lang natin yung pareho. Alright, so papalitan natin siya. Ito, yung ating current IP allocation. So based on sa ating diagram, we will have yung, if you go, punta kayo dun sa yung sa baba di ba yung binigay kong diagram na 3 router, 3 network lab scenario. Yung ginamit natin kanina is yung nasa taas. Okay? Actually, let me share that again with you. Para malinaw tayo. So, pakita ko lang ulit. Okay? So, dito tayo kanina, di ba? This is where we're coming from. Ito yung ginawa natin. Puro /24 networks. So, ito yung goal natin ngayon, this time around. Okay? So, we'll renumber. Palitan natin lahat ng IP addresses 192.168.10 dito. That's /30. 192.168.10.4/30 dito. And then 192.168.10.8/30 dito sa baba. Okay? So, ito yung mga respective IP addresses ng bawat interfaces. 10.5, 10.6, 10.9, 10.10. Okay? So, we'll do this exact IP address allocation dun sa lab natin. Okay? So, I'll switch back over to my console. You can keep that open on a separate window. Yung diagram natin. Okay. Right. So, let's change yung IP addresses. In this case, we'll start with BSRX1. Palitan natin yung between BSRX1 and BSRX2. Okay? So, bali yung 10.19 and 12 network, papalitan natin ng 192.168.10.0/30 na network. Okay? So, that means, ito, delete natin to. Okay? So, babaguhin natin siya 192.168.10.1/30. 10.1/30. Okay? And so, bali, nagbago lang. Okay, palitan lang natin yung IP address. Alright, so let's do yung other side muna. Let's take it one segment at a time. So, in this case, sa side ni VSRX2, ang katapat nun is 002. Okay? Show interfaces. Okay? So, pakita na rin natin yung 001 dito. Para lang. So, ito yung katapat natin kanina. So, papalitan lang din natin to. Oops. Okay. And then we'll replace it with 192.168.10.2.
2/30. Okay? So, commit natin yan. And then we'll try to ping from VSRX1. Okay, so that's done. And it works. Okay? So now from VSRX1, let's do from VSRX1 to VSRX3, which is nandun yung 192.168.10.4/13 na network. So that 5 CVSRX1, that 6 CVSRX3. So let's try to replace yung existing IP address. Ito siya, yung 1099.13 network. Ito yung papalitan natin. Okay. So, palitan natin yan. Then we'll replace it with 192.168. So, si VSRX1 is chassis.5. Okay. So, yan. So, chassis.5. Commit that. And we'll hop on over to VSRX3. Okay. So, si VSRX3 is... Ipakita na lang natin. So, interfaces, GE. Okay, so ito yung dalawang interface niya. So ito yung current configuration. No? Kung katapat ni VSRX1 kay VSRX3 would be yung 001. Okay, so ito yung kanina. Ito yung ngayon actually. So, papalitan natin yan. So we'll do 192.168.10.6, right? That's 6. One is 192.168.10.6. So let's ping that from VSRX1. Natapos to. Okay, there you go. So let's try to ping. And it works. Okay, so nag-uusap na yung VSRX1 to VSRX3 segment. So finally, yung VSRX2 to VSRX3. And the one we'll be configuring is yung 001. So, okay, so yung 23 network kanina. 1099.23.network. Replace natin siya. Okay, so we'll set a new IP address which is 192.168. Ano siya? Ito yung 10.8/30 network, no? So, mangyari is TIC.9 dito sa BSRX2. 10.9/30. 192.168.10.9. Okay? So, try to make that change. Hop on over to VSRX3. So, ang existing ngayon sa VSRX3 would be 1099.23.3. Okay? So, ito yung papalitan natin. Okay? So, we will be 192.168.10.10/30. Oops, mali dito. Okay. So now that we have that, we should be able to ping between VSRX2 and VSRX3. So from VSRX2, and it works. Okay. So yun. Yeah. So that's it. That's how you renumber your network mo for a more efficient IP addressing scheme. Okay. Subnetting mo. Yung pagkakasubnet ng network mo. Okay? So yun. Let's give time for some questions if there are any questions. Okay? Ayun, love demo nila. Okay, any questions? Questions, anyone? Okay, so I understand you might have to review itong webinar na to one more time or maybe twice. Okay, so kung walang questions, that means we will finish early for our webinar. Okay, and so go through this a few more times, okay, para ma-absorb lahat ng mga pinag-usapan natin dito. Okay, I know it's kumbaga the binary part and the math part are may be kumbaga something na may kailangan mo ulit-ulitin kumbaga. So I did the same thing obviously nung inaaral ko to. So that's quite normal, okay? No problem with that. So as usual, you can you can always just send me questions through email if meron kayong pahabol na questions after this session. Okay? And or you can message me in any of my social media channels, Facebook, Instagram, Twitter. Para-pareho lang naman, I am zero slash. And also, I'd like to remind you na yung webinar surveys na pinapadala ko, it would really help me a lot if you would provide your feedback, positive or negative. It helps. Everything helps to make the webinars better. Okay? So I appreciate if you participate dun sa survey. Okay? And as usual, yung webinar recording will stay up for 1 week. If you need any extension, just let me know. Wala namang problema nun. I can extend it for you. And that's about it. I'll see you in the next webinar. Okay? Which is you'll just it's 2 weeks from now. You'll be notified. You'll receive yung webinar announcement tsaka yung 3 days before ng webinar na notification. Okay? Okay, so that's all for our session for tonight, and I'll see you next time. Okay? Bye.